on, computer. There we go. Okay. So, section 1-2, measuring and constructing segments. And like I said, first thing we're going to look at is this thing called the ruler postulate. You guys remember back when you were doing all the prerequisite skills stuff on that little worksheet I had to do the very first day? You had all that absolute value work. Okay? This is going to be related to that. So if you have a line segment that you want to measure, I kind of feel silly even doing this, but okay, so let's say we've got this segment. I just drew a random segment on my page with my straight edge. I didn't look to see how long it was. And we're going to just call it AB. So the ruler postulate says if you put a ruler on or next to a segment, okay, if you subtract the two numbers, that's the length of the segment. Ooh, big surprise. So, you know, it's kind of silly. I think part of me feels like the ruler postulate is kind of pointless because you could always just put the ruler at 0, right? And then see exactly how long it is. In this case, it's 5. What do we got there? Centimeters? 5 centimeters. The ruler postulate applies really more to if you put it down and then it's two numbers where you're not starting at 0. Okay. So I've got 18 and 23. Okay. So assuming that that's the two numbers I wanted to use, then the length of AB would be equal to 23 minus 18, and it's the absolute value of that, because it's a distance, so it's always positive. And that would be the absolute value of 5, which is 5. Okay? Now, that being said, you really don't need the ruler postulate. You can always just start it at 0 and measure it, and it's easy. You've done it before. But in general, that's how it works. Now, while we're doing this, though, it's important to note a little notation thing here with this. This AB. Notice how we're talking about line segment AB, but I didn't put the little bar on the top this time. Okay, do you guys know why I didn't do that? Okay, I'll tell you. AB with the bar refers to the segment. So this is line segment AB. If I have AB, that refers to the length of line segment AB. Okay, so that's an important thing that you guys need to know. Okay, and to make sure that when you're talking about the length of a segment, you're not putting the bar on there, or if you're just talking about the segment, you do have the bar on there. It's an important notation thing that can make a big difference later on. So the next thing we're going to jump to, because I think that's all I really want to talk about with the ruler postulate, is congruency. And more specifically, congruent segments. Have you guys ever heard of the word congruent before? Did they use that in any of your middle school classes or anything in math? Yeah. You have heard it before. Okay, so what do you remember about it? Yeah. Same. Generally means the same. Can we be any more specific than that, though? If I have congruent segments, what does that mean about the two segments then? Yeah. Nope, it doesn't mean that they're parallel. Good guess, though. Think about it. In general, congruent means the same. So what if I have two congruent segments? What do you suppose is the same about them? They have the same length. Exactly. So that's what we're going to focus on. Congruent segments have the same length. Okay, and so this is going to come back to that notation stuff that we talked about up here with if you put the bar on the top, it's talking about the segment. Without the bar, it's the length. Okay? Because this thing with congruent segments, people screw this up all the time. So this statement, let's say I've got two segments. We'll go with CD. Let's say CD, I've measured it, it's 2 inches long. And I've got some other segment over here. EF, I've measured it, it's 2 inches long. So I know that the line segment CD and the line segment EF are congruent line segments, right? They're the same length, they're congruent. So there are two different statements that I could make here then. Okay? The first statement is CD is congruent to EF. And that would look like this. The symbol for congruent, if you remember, is an equal sign with a little squiggle on the top. So that statement reads, line segment CD is congruent to line segment EF. Okay? Now another statement, which is also true, but is not exactly the same thing as this, would be that the length of CD is equal to the length of EF. So CD is equal to EF. Remember, no bar means length of. So the length of CD is equal, not congruent, equal to the length of EF. Because what sorts of things can be equal? Numbers, right? The length of this is 2. The length of this is 2. So the lengths of them are equal. The segments themselves can't be equal, okay? Equal only refers to numbers, okay? So congruent is what we use then. So the line segment CD is congruent to line segment EF, but the length of CD is equal to the length of EF. You guys see the difference? Okay, that's going to be an important thing moving forward. So comparing some segments for congruence. We'll do a little example of this then. And we're going to give you guys a little practice in the coordinate plane here, because maybe it's been a little while. So let's say I've got some coordinates here, or some points with some coordinates. Oops. So we'll do point J. It's going to be at -3, 4. K is at 2, 4. L is at 1, 3. And M is at 1, -2. So the first thing we're going to do is we're going to plot those 4 points. Now, I didn't give you guys any graph paper, but that's okay. This is going to be an important skill we're going to practice here, which is creating a coordinate plane just on a regular piece of paper. Okay? It doesn't have to be super neat and tidy, but at the same time, it has to have a little bit of order to it so you can actually see what it is that you're doing. So use the blue lines, those horizontal lines, to help kind of space things out for you. Okay? So we know that our x's, we've got -3, 2, and 1. So we need to make our x-axis big enough to have all of those. And our y's, we have 4, 4, 3, and -2. So if we go out like 4 in every direction, we should have enough room to plot these 4 points then. Okay? So that's what we're going to do. We're going to make a coordinate plane that's big enough we can go out to 4 every direction. And so I'll just go like every line is 2, and that'll get us out there. When you do this kind of graphing by hand, like I said, I'm not looking for like real, perfect, pristine stuff. But at the very least, I'm going to look for scale. You have to have some sort of scale, otherwise it's meaningless. So put numbers on your axes. That's what I mean by scale. Okay, so I know what you're counting by with each little tick mark, so we know if we've got things in the right place or not. Okay, so let's quickly plot these points then. So j is negative 3 in the x and then up to 4. So there's j. K is at 2, 4. L is at 1, 3. And M is 1, negative 2. So that's going to kind of get in the way there. So right down there, that's M. Okay, so there are 4 points. And so we're going to try and figure out if JK and LM are congruent. So, how can we do that? If they are congruent, what should be true? Should be the same length. Can we figure out if they're the same length when they're on a coordinate plane like that? Certainly. Okay. So, JK. How long is JK? Yeah. 5. Okay. Negative 3 to 2. Okay, if you wanted to do the way that we were doing, like the ruler postulate up above with the whole absolute value business, you can do that. Or the method I like to use, which I think is a little simpler for you guys, count. Okay, count the tick marks. 1, 2, 3, 4, 5. It's 5 across. Okay, so that has a length of 5. What about LM? We can measure that as well. How long is LM? 5. Just count it up and down, right? Don't need to worry about what the numbers are. Just count the tick marks if you labeled it right. 1, 2, 3, 4, 5. Okay, so do we have congruent segments? Yep. That was easy. So, because the length of JK is equal to the length of LM, then JK is congruent to LM. We got it, okay? So that's one way that you can check for congruency, okay? Just count, see how far apart they are. What we're going to focus the rest of the time today is on this thing called the segment addition postulate. And it's a pretty straightforward little postulate. And you use it all the time and probably don't even realize it, if you ever do any kind of measuring at home or whatever. Dope. Anybody in here ever do like any kind of like home improvement stuff, like you work with one of your parents and like fix up a bathroom or whatever? You guys ever done that before? Anybody have parents that work construction, that sort of thing or whatever? Guarantee you they do this all the time. Okay? If they're trying to measure out, you know, a floor plan or whatever they're working on to make sure they've got things so it's going to fit. The segment addition postulate, whether they probably don't call it that, they probably don't realize that they're doing it, but it's a way to help measure things kind of indirectly. So here's what it says. If B is between A and C, then AB plus BC equals AC. All right, and I'll even draw you a little picture next to it here that if it's not clear, hopefully it'll make it clear. So B is between A and C. Okay, so this last little part then, AB plus BC equals AC. Do you see that in the picture? Yeah. Right? The length of this segment plus the length of this segment is the whole thing. Makes sense, right? Okay. Well, here's how the segment addition postulate gets used quite often. Let's say you know the length of AB and you know the length of AC, and you want to know the length of BC. So what do you need to do? Subtract them. Okay? That's the kind of thing I was talking about that gets used quite often. Is if you want to know a measurement and you already have ones, you can do a simple subtraction and get what you need. Okay? And that's using the segment addition postulate. All right? So I'm going to do a quick example with that. So all right. So we've got this situation where n is between m and p. It's not exactly in the middle, but it's in between them. Just has to be in between them. I know the length of NP is 37. I know the length of MP is 54. And I want to know how long is MN. So what's the answer? 17. Yeah. Yep. All right. So let's try, bless you. Let's try another example. And this time I'm going to throw a little algebra in the mix. See if you guys can still hang with me here. All right, what if I did it like that? Still use the segment addition postulate for this. Oh, I should probably label those points. Let's say we've got Q, R, S. And I want to know what's the value of X. And then I also want to know what's the length of QR. So, what do you think? How could I do this one? I'll give you a hint. I'm going to have to make an equation somehow. What's equal to what in the picture here? Yeah.
It's going to be 10x minus 1. Is that going to be the equation?
Nope. You got the right idea, though, but you didn't quite do the right thing. Yeah.
Isn't it 2x plus 5x minus 1?
Yeah, exactly. The two parts, these both add together to give you 28, right? The length of QR, the length of RS should add to give you 28. You just multiplied it. All right, so that's going to be our equation. 2x plus 5x minus 1 equals 28. And now we got a little bit of algebra to do to solve this and then use that to help us. Okay, so if we combine some like terms together here, 2x plus 5x is 7x. And then if I add the 1 to the other side, so 7x equals 29. And then we got to divide by 7. Ew, that's no good. Well, I guess we'll just have to use a fraction. So your answer would be 29/7. And that's okay. We'll have answers later that come out like that quite a bit. All right, so we answered one part. X is 29/7. And then I also want to know what's the length of QR. So how might I find QR then? Let's have somebody else who hasn't. Yeah, go ahead. Right. So QR is equal to 2x, so it's equal to 2 times 29 sevenths. And who's real good with fractions? What's 2 times 29 sevenths? Yeah?
58 14.
Oh, you're close. It's not 58 fourteenths. It's 58 sevenths. Yeah. Think of it as like 2 over 1 times 29 over 7, and then 1 times 7. Yeah, so 58 sevenths would be the length of QR. Yeah, good. Okay. We'll work more with that in the future. And you've got some in your homework, too, that are like some story problem ones. Just using that segment addition postulate as part of it. So, good. So that's all I got for you today. So your homework we will get to next year. You guys have the rest of the time to work on that.